Hooray! All right. Hello.
Hello.
So, pandas. Yes,
Yeah.
we're gonna do a
Yes.
next
Lesson two.
session. So, yeah, I think what's a good way to start this? What did we learn last time?
So we learned how to import a CSV file using
Yep,
pandas.
that's right.
We learned how to summarize, how to uh, extract a brief summary of the data, and then
Mm-hmm.
we
Yep.
learned how to look at the first few rows and how to sort of change the entries, and
Mm-hmm.
also learned how to create our own data frames
Yep.
and learned how to deal with not a number cells.
Yeah, that's a pretty good summary. I think
Right,
these are
cool.
like the toolkits that you'll need to process some data in a data sciencey
Hmm.
position.
Yeah,
And if you can remember these functionalities, it would just be worthwhile so that you don't have to look up every single time the documentation stuff. But it's pretty hard to
yeah,
remember all of this stuff. So I
yeah,
think a lot of practice is necessary to start to feel comfortable. Just like, if you learned how to use Excel, you just got to keep using it until you get really familiar with that.
yeah, yeah.
So if we
Cool.
go back to the tutorial, we finished
Hmm.
off tutorial 3. So let's try and finish this um,
Four.
4. So grouping
Yeah.
and sorting. So I might just make a new Jupyter notebook, and
Okay.
I'll just call this 002 Pandas 2020. All right. All right. So what does this go into? So,
Hmm.
so they're using a function called group by on a data frame. So the first things first, let's import our
Hmm.
data frame. If we
Hmm.
look at the way that we did it last time using read CSV, we can just hijack that and do the same thing.
Yep.
So let's copy that and import pandas as PD. And then we want to go pd.read CSV iris file.
Hmm.
So this should give us a data set, and we have
Okay.
that. Okay, so if we read what this says, it's saying that we can transform this data frame or a series by grouping the data. So if we think about the word group, we can sort of
Hmm.
we can infer that if we have, say, species, if we group it by species, we will get all the values of the
Hmm.
species grouped together. So Setosa by itself, Virginica by itself.
Yeah.
How do we get these distinct values of species? Do you remember?
Distinct values for like all the values belong to a specific species.
Yeah, just like give me a
Okay.
summary of what the values could be.
Oh, the summaries. Right. So, describe.
So if I did species.describe,
Oh, oh, right. Okay.
so that gives me the top
Yeah.
and the unique number, but I actually want what the unique values are. So one thing you can do is if you don't know, you can write dir and then just write the species. Um, you can write the object that you get out. So this is getting the specific series. Um,
Hmm.
so this is the series data.
Yep.
And if we
Hmm.
want to find all the methods on that, we can just write dir.
Okay.
And if we just search for like unique or something like that, it might.
Ah, right.
So there we go.
Yeah.
So what this tells me is like these are the three values in
Hmm.
this thing, and if
Okay.
we go by also value counts is a way to do it that they specify. So if you do value counts, we
Hmm.
can see how many times Setosa was added,
Oh, cool.
Virginica. Yep.
Yep.
So if we did group
Um.
by on this data frame, we can potentially grab the different values and group them. Now, why is that useful? So, oops. So in this example, they group by points. So what happens if we do df.group by species? What do we get? So we get this pandas group by object, and this is not very clear like what that means, but if we look at the methods on this, we can see that there's actually quite a lot of methods, but
so I just have a quick question.
Yeah.
For that dir dir thing, like, so is that like general Python command?
Yeah, it's a general Python command that you can do on any Python object. So if I did it on like a character, this tells me what methods I can do on the character.
I see. Yep.
So all of these things that are, ignore the underscore for now. All of these things are methods that you can potentially access, or properties. So if I do like a dot casefold, that's an actual function that you can call, and you can see, you can call that. It's worth knowing that, yeah.
Cool.
So in this example, what they say is like they group by points, but it created a group of reviews which allotted the same point values to the group, to the given wines. Then for each groups, we grabbed the points column and counted how many times it appeared. Value counts is just a shortcut to this group by operation. We can use any summary function we've used before with this data. For example, so see how it's done like this thing where by calling value counts, it aggregated the number of times Setosa was in species.
Yeah.
So like df.species is like a list of all these values, right? And it's exactly 150 long. When you do value counts, it's actually doing a form of group by where it groups all the values. In this case, Setosa, whenever it sees Setosa, it groups all of them, and it does like an incremental count. So it counts how many times you see Setosa. Can you think of it? Sorry, go on.
What's the difference then between the two?
Well, this allows you to do it other things than just counting how many times it appears. Like if you think about an aggregate function, can you name me like another aggregate function that comes to mind? Like an aggregate is just like based on going through this 150 items, right? Every time I see Setosa, I can aggregate it by aggregating, say, a count. So I +1. But you could do the reverse. Like you could do -1. That's an aggregate function. So this allows you to do some sort of aggregation based on what you see here. So if I did say, if I looked at the DF and I did group by and species, it gives me this group by object based on the values in species. And I could aggregate on any of these. So I could just aggregate on, say, sepal length, I think, .min.
Wow.
So what that's saying is that given all of the values that have Setosa, find the minimum value for sepal length out of all of these, and that's what you find for the species Setosa. So you could ask, what is the minimum sepal width, and then you would do the same thing, but you would use sepal width instead.
Okay, that's I see. That's more useful than value counts.
Yeah.
Okay. Yeah.
And I believe that when you do this group by as well, There's another way that you can access this, which is by iterating through the group. So,
Yeah.
Is there like a, I think if I just do like for I in this, right? What do I get?
Oh.
Do I get something? Yeah.
Oh. What is?
Okay, so this is interesting. What this gives you, and I'll just like break here. So what it does is, sorry, just let me just find out what this type I is. It's a tuple. Okay,
Tuple.
so you actually get, when you do for I in group by species, you actually get a tuple for every value in here. Okay, do you know what a tuple is?
Is it like a vector?
It
Like a
is like a vector, yes.
Yeah.
It is like a vector.
Yeah.
So if I get the first tuple,
Yeah.
I can call next on this. Oh, it's not an iterator.
Oh.
Is there, how do I get the first thing? Is there like an iter item? How do I get the first thing? Can I do this, maybe? Column not zero, okay. All right, whatever. Let me just get the first item by going for first tuple in A, and then we'll just break, and then we'll get the first tuple. Okay, so my question to you was, what is a tuple? And yes,
Yeah.
you're right. It's like a vector. It's like a list. So like, the first one's a tuple where you can index the first thing by 0 and the second thing by 1.
Yeah.
And it's the same with a list. So you've got the first thing is 1 and the second thing is 2.
Yeah.
The value that you get out of here when you iterate through this group by is you get a tuple. And what's the first thing? So let's just have a look. If we do first tuple 0, we get the name of the species, Setosa. And if we do first tuple 1, we actually get a data frame. So if you were to guess, right?
Yeah.
What would be the next iteration of this? What would you get?
The next one would be versicolor and the data frame corresponding to that.
Correct. Yes.
Yeah.
So it allows you to just reference a subset of the data frame that it grouped by. And that could be useful to you if you wanted to say just work on a data frame that contained only Setosa and a data frame that only contained, you know, versicolor or whatever. So that's pretty useful.
Yeah.
So we learned that we can aggregate when we group by, we can iterate. It does apply. Do you remember what apply does?
Yeah, so you create your own function and then yeah. Okay.
So let's practice this by like creating our own function. But I'll leave this to you. Create me a function that I can use apply on for just the Setosa data frame that we get from group by.
Okay.
Yeah.
So I guess the example just to add like 20 to sepal width.
Okay. So how do we write a function that's going to add? Yeah.
Well, let's call that add 20. Yeah.
And what would be the parameter that this method takes?
Let me think. Row, right?
Mm-hmm.
Yeah. And then row dot sepal width plus equal 20. Yep. And then return row. You have to do return row, yeah, specifically.
Okay.
Right. So let's try if that works. Dots, apply lambda. Yep. and then we call our data frame. This case, yep, data frame df dot. Oh, interesting.
Yeah, so this one's a bit confusing because it's a bit different to what we did. I think the way that we did it was we just added the function name and then we did access 1.
Ah, yeah. Okay.
Yeah.
Yeah.
So this did the addition of that.
Yeah.
But I think in this case, what they have is a Lambda function that takes the data frame itself because remember this returns this doesn't return one data frame, it returns many data frames.
That's right, yeah.
So actually it's doing it on all of the data frames that it gets, so the Lambda is no longer a series, a row, sorry. It's actually the full thing.
Right.
Yeah.
Right, yeah. So for each data frame we do is you find a title and print the first title.
In this case, it is going to, print the first title. Yeah, that's right. It doesn't seem to be mutating anything. It just, shows that.
Okay.
So for more functions, you can use more than one column, right? So instead of just species, we could group by petal width.
Yeah.
So if we did df.group by, and then we give it a list species petal width, we get that. And if we, I want to figure out how to get the first data frame. Instead of doing this for I and whatever, there must be a way to iterate through this. So I'll just go G is that, and let's work this out by looking at the dir. So it has this thing, .iter. I think if I do like g.iter, right? What that actually does is give me a method to getting a call, but that's okay. I'm just gonna like ignore that.
Okay.
Yeah, so what I'm going to explain to you is something that's a little bit advanced. When you do, when you have like a list, for example, when you what you do when you do for I in A is you're iterating over the list.
Yep.
So that's an important word, iterate. Okay.
Yeah.
And the key thing about this is that this list has an iterator. It has this notion of having the ability to iterate over its contents. So underneath the hood, underneath Python's hood for list, there's this way that it's associated this list to having an iterator.
Oh, okay.
And the same thing is like when you see this dot underscore underscore iter, it tells me that they've associated this group by type, which you see here, to have an iterator as well. And I'm accessing that iterator by doing this thing. It's a bit advanced, and I would say don't worry about it too much. But what that allows me to do, I think, is to call next on that. And if I get rid of this, okay, cool. So that's how I access the first item.
Wow. Okay.
And the first item was a tuple, as we remember, which had, in this case, the first item now for the first item tuple is actually another tuple.
I'm just wondering if you do, so you create a list A. What if you did A dot, like underscore, iter? Would that be similar?
Okay.
To,
that's a good question. So in A, if we look at the dir, we can see that it has iter as well. And sorry. And if I did the same thing where I wanted to get the first item, right? I can do exactly the same thing by calling next on a.iter, and I get 1. So this under the hood, that's what Python kind of does. It allows you to iterate over a collection of things because it has implemented a method
Yeah.
that has this underscore underscore iter. It's a special thing.
Yeah.
And if you write your own classes, you can make them iterable such that I can do like for I in my class. By making this my class making sure that it's defined this iter function.
Ah,
Yeah.
interesting. Okay.
So the key thing is like when we did group by and we had this list, we get back two values now for the first
Yeah.
thing. And what about the data frame? If we actually look at the data frame, we can see that it's grouped. So the combination of these two. So it's only the data frame that contains
Oh, that's really
0.1
cool.
and yeah. If we
Yeah.
did next on the iterable again,
Yeah.
we will get the
Um.
next value.
Oh, wait. Is
So
that the
wait a sec.
same?
Yeah, I should get the next. How do I get the next one? I think I have to store this. Let me just say it is equal to this, and then we go next it, and then we go next it. There we go. Yeah. So it
Oh,
wasn't. It was.
how? What's the difference? Hey.
It's a bit confusing, but because I wasn't storing this, it
Yeah.
was still at the first iteration, and then when I
Oh, that's so confusing. Right.
yeah,
Okay.
I wouldn't worry about it too much at the moment.
Right. Yeah.
It's
Yeah.
more
No
advanced
worries.
stuff.
Yeah.
But what we can see here is that we have the next value, which is that 0.2 with Setosa. And if we keep,
Just
if we,
yeah. Just like a side question. Did you learn this when you were doing, the CS course, or did you learn this on the job? On the job.
a lot of it's just on the job. Um,
Oh. Okay.
well, it's kind of like you get taught a little bit about it, but it's not
Mm-hmm.
really like this is a feature of a language. It's kind of like at some point you will encounter this, and it
Mm.
will feel a little bit complex, but the more and more you
Mm.
use it, the more you'll realize what it will
Mm-hmm.
do. So don't worry about it too much at the moment.
Yeah. Yeah. No, that's interesting.
Yeah.
All right.
So we've got this. Yeah, so we've done it on two.
Mm-hmm.
And then it's just showing us that there is an ag function that lets
Yeah.
you run a bunch of different functions on your data frame simultaneously.
Mm-hmm.
So instead of just doing like one function like min, max, you can just aggregate them all, and it will give you that as a data frame.
Wow. Yeah. That's a bit. Yeah. That's getting complex. Okay.
Yeah, just think of the simple one, which is like if you do like one of those aggregate functions, like in
Yeah.
Setosa, if we
Mm-hmm.
did a min on that, it would just get the minimum. But if we had like min, max, and len, it would just have three columns that show what
Yeah.
the yeah what they are for this.
So ag is basically like applying. If you want to apply more than one function, you do.
Yeah, that's right. So if I
Yeah.
did like species and then I
Mm-hmm.
did dot ag,
Yeah.
how does it work? Yeah. So I give it the function. So I give it min. Let's just do the one.
Mm-hmm.
So it's got the min for all of the values in this
Mm-hmm.
thing. And if I do max, it gives me the min max for each column for Setosa and all that
Yeah.
stuff. And then if I do len, yeah.
Wow.
So that just avoids you having to write a lot of code if you know how to
Mm.
do this type of stuff, which is quite useful.
Yeah. Yeah. It is very useful.
Okay, so we now are looking at multi-indexes. So instead of having a single index, do you remember how we have an index here? This
Mm-hmm.
is an index. We could have multiple indexes as well um, for like one
Ah, like
row.
it could be like 0, 1, 2, something like that.
Something like that, yeah.
Mm. Okay.
Um, I don't think it's like I don't use that. I haven't used that much, but
Okay.
So I actually think it's something like very specific to
Mm.
um I just I don't think it's worth knowing,
Yeah.
honestly.
Okay.
I think we can skip this one.
Let's do it. Yeah.
So
Okay.
sorting. So based on this, they call this reset index, which we've seen previously.
Hmm.
If I call reset index, what will
Yeah.
happen is that it will make this 0, 1, 2. So if
Hmm.
I do reset index, yeah, you can see that it moves this into its own column and makes that
Yeah.
index 0, 1, 2.
Hmm.
Um, but it has the ability to sort the values, and the sorting is going to be on the index, but you can specify what to sort it on. So at the moment, um, we can see like what's a good example? This is actually sorted, so it's not a very good. Here we go. So we can see like the min is
Yep.
higher than this, but
Yep.
if we sorted this such that we put it in some df2 and then we wanted to order it such that the rows represent the min values. So we could do df2 dot sort values by, and I'm gonna try this min. I'm not sure if this will work.
Oh.
Yeah. So there's many mins, unfortunately.
Yes. Yeah.
So we actually need to figure out how to get this specific index um, and sort it by that
What?
instead.
Right. Yeah. Well, you are saying that sort by the mean for sepal width very
Yeah.
specifically.
So how do you reference this multi-index where it's the
Hmm.
column? So we have this like multi-index data frame for column.
Hmm.
So instead of it being this way, it's like top wise. We can see like there's two indexes for the columns that we see here.
Yeah.
And I did tell you to not that we don't need to learn it, but
Hmm.
unfortunately we actually do have it here.
Okay. That's all
So
right.
this is creating it, but what if we have one that has it? I'm just trying to quickly. Yeah, so here's an
Hmm.
example where we have bar and one um, as the indexes. So how do they access it? Basing index on axis. I don't see the multi-index. Okay, I actually honestly think this is a really bad example because you will never get this where you've got all of,
Hmm. Yeah.
duplicate fields. Like that's just, I think, bad practice.
Okay.
Although I'm not like an expert data science, but I believe
Yeah.
that's not what you do. So let's
Okay.
just say with df, yeah, we want to sort on sepal length. So we would just
Hmm.
go sort values by sepal length. Oops. And what we should see is yeah, so we can see that now it's re-indexed everything,
Huh.
but
Interesting.
we can see here that it's in ascending from
Yeah.
smallest sepal length up. So that could be very useful, right? Let's
Hmm.
say we did the computer part thing. If you had a data frame with like an aggregate of all the prices based on some configurations or whatever that
Yeah.
you calculate, and you just want
Hmm.
to sort by the price, you can see how
Yeah.
this would be useful, right?
Yeah.
Um, and then because you can see that the indexes are now screwed up, I believe
Hmm.
that what we want to do is if we say like,
Save that and reset.
yeah, that's right, sorted by sepal length, we now want to make sure that when we index this, right, if we do like iloc 0, which
Uh-huh.
is the first index, sorted, that's not going to be the first one. That's going to be, oh, actually, it was the
It
first
is the
one.
best one. Yeah.
So
That's interesting.
So I'm not sure, like the I
Maybe
lock.
maybe zero is
Oh, sorry, no, by
better than
lock.
one.
If you did by lock, the like lock zero, you won't get the first one.
What's the difference between high lock and now?
So this is an index, right?
Yeah.
But if you did iLock, it's actually not looking at the index and it's looking at the order in which you,
Oh
yeah,
yeah,
yeah.
right.
So this
So
will
lock is actually
always
literally looking at
the
the value.
value exactly,
Yeah.
and the value can be like something different, like dog or cat or whatever. Um,
Oh
yeah.
right.
But when you
Hmm.
reset the index,
Yeah, I'm
all
sorry,
of
I've got to
those.
take a phone call.
Oh
I'm
yeah,
just
no
gonna
worries.
mute myself for 1 second.
All right, no worries. I'll just keep going. So yeah, like if you reset the indexes and like those indexes have like some sort of label, it will actually move all those into this column and then set these to values. Okay, so we know how to sort. We've done the group by. We can move on to the next one, I guess. So let's go notebooks. Oh, sorry, let's go back and then go to the next lesson. And why can't I? Yeah. Okay. So in this lesson, they talk about D types.
Alright, I'm back.
Oh, yep, no worries.
Alright. So
So,
where are we up to?
so we're up to the next one, which is
Mm-hmm.
talking about D types.
Okay, data types.
Yep.
This is something we covered in the first
Do you remember
lesson.
what data types exists?
Yeah, so there's like floats 64, int
Mm-hmm.
64.
Yep.
There's like char. Oh no,
Objects.
there's
No,
object.
no.
Yeah, object.
Yeah, there's no
Yeah,
chart. There's just object.
there's object. Yeah.
Yep. Those are the primary ones. So it's like
Okay.
numerical types that
Mm-hmm.
if you're going to do some sort of numerical analysis,
Yep.
it's best to put them in the correct form. And
Okay.
one thing that I'll allude you to is that
Yeah.
this float 64 means like a 64-bit float, but
Yeah.
you can have like numbers that require less bits. And the
Mm-hmm.
reason why that might be useful is because your data doesn't need to. Um, so, what does 64 mean? Do you know?
64-bit.
Yeah.
Right.
So,
So
what's a bit
the bit is a 0, 1.
exactly?
So 64 is like 64 digits in terms of zeros and ones.
Exactly. So, what do you know?
Yeah.
Do you know what potentially is the largest number that you can get
With
with?
64,
Yeah,
that's 2 to the power 64
that's right. So,
plus 1 or something, is it? I don't know.
-1, I think, but
Minus 1. Okay. Yeah.
because you include zero. But
Yeah.
the key thing there is like it's actually not
Yeah.
that. It's actually less because of the way that it stores the numbers and stuff. But
Mm.
that's a pretty big number, and
Yeah.
sometimes your data doesn't need that. So if your
Yeah.
accuracy or precision can be lower, what you can do is you can
Mm-hmm.
change this to a different number,
Mm.
like 32 or something like that. I'm not sure if Pandas supports those D types, but in other languages and other implementations, you want to do that for performance,
Mm.
but it does have an impact on your precision. So, like, the more
Yeah.
precise you need to be,
Yeah.
the more memory that you might need.
Yeah.
And
Yeah. Yeah. Okay.
like just also like if you don't need floats and you
Yeah.
just require integers, like there's a lot of
Yeah.
discrete statistical stuff that doesn't require any floats, so you might just go with that as well.
Yeah. Is there a 128?
128, yeah. So that like a lot of
For float?
mathematical, yeah. So they call that like a double,
Yeah.
because they can store the number in multiple like floats or
Right.
whatever. So they just
Mm-hmm.
combine the two. I mean, this is
Okay.
sort of getting into more computer science theory, which
Yeah.
it's worth understanding at some point.
Yeah.
But I guess like similarly with like the quantum mechanics stuff, how do they store the numbers in terms of the machinery? Is there a limit to the amount of numbers that you can store in the quantum computing space?
Well, in quantum computing, it depends how many qubits you have. So I guess you can store
As
as many qubits as you have at the
But is it
moment.
still 2 to the power of number of qubits in terms of the number?
Yes, yeah, it is. It
Okay.
is. Yeah,
Okay. So it's
yeah,
directly the same then.
yeah.
Like
But the
very similar
difference,
concepts.
yeah, but the difference is that depending on how so there's a concept called entanglement. So it depends on how entangled the system is. For example, you have 10 qubits, so you can say that classically there's 2 to the power of 10, combinations. But because the quantum property, you might have an integer multiple of 2 to the 2 to the power of 10, just because the qubits, they can be in
Yep.
a multiple states at the same time.
Okay. So
Yeah,
it's
so
another factor to think about.
that's right. Yeah.
I would love to like learn more about that at some
Yeah,
point.
yeah, of course.
We can do a session.
Yeah.
Okay, so we looked at this where we used
Hmm.
np dot not a number. So like
Hmm.
if I did panda.nan, that doesn't exist. I have
Yeah.
to import numpy as np and do np.nan to get not a
Hmm.
number. And we saw that the PD itself has a is null check, which we can use. So if we go is null np.nan, that's true because it's
Yeah.
checking that. And if we do it on, say, a series, let's try that. So we go df dot sepal length.
Can you do it on the whole data frame or?
Yeah, right. I'll try that next,
Yeah.
but let's just
Okay.
try it on this first.
Okay.
And so what you get is like a series of booleans that say
Hmm.
which ones are false because it's not null. And so if
Yeah.
I plug that into the data frame, is null df.sepal length, it should give me nothing. And the
Yeah.
reason why is because they're all false. But if we do the reverse of this, so one thing that we haven't covered is in this filtering,
Hmm.
where we're filtering everything that's true, right?
Hmm.
What if we want to be opposite of this? So what if we
Yeah.
want to do not this? Can I
Yeah.
just call normally in normal Python if you have like not true,
Yeah.
that should work. So if I write not, maybe I'm not sure. Nope. So I think the answer might be that, and it's
Oh,
confusing, but
negative.
the
Huh.
negation of this filtering inside here
Mm.
is actually a squiggly thing.
Oh, it's a
So
squiggle. Sorry, on my screen because it's not pixelated. So
that's all right. So you use
yeah.
the shift button next to one,
Hmm.
the squiggle. Yeah.
Yeah. Yep. Yep.
Um,
Oh
and
yeah, makes sense. Yeah.
yeah. And so yesterday, I think last time we added an NaN, which we can do
Hmm.
again. So we go
Yeah.
df2 equals, if we just go df, yeah, how do we appended it, right? So we
Yeah, we
end,
appended it. Yeah, so we had to create a new data frame. We had
yeah,
to do it manually.
which
Yeah.
if there was a better way, I would like to know.
Yeah, me too.
And we just mp.nan, sepal width, and pedal width.
As always. And then let's make sure that we
Yep,
index this thing as well to 150.
yep, that's a good idea. How do I do that?
So you just comma or and then index, yeah, equal, I think just do 150.
Yep.
Yeah, see if that works. Okay. I wonder. Okay, let's do two things because I'm thinking, what if you just append it and then you would just gives an index automatically. So let's try both and see if
Okay.
Oh, okay. It actually, yeah, 0. So let's see if you appended that. It doesn't. Yeah, so it doesn't do that automatically. You have to manually do that.
Right. I mean, you could do that and then reset it. That's the
Yeah,
other
true,
way.
true, true, true.
So you have those two options.
True.
So now we have that. If we did
Mm-hmm.
df
Mm-hmm.
pd is null again,
Mm-hmm.
we should get. Oh yeah, you want to see pd is null on the data frame.
Mm-hmm.
And that's what we got yesterday. Yeah, with
Yeah.
everything.
Mm-hmm.
But
Yeah.
the filtering only happens on. You can't specify another like a data frame in the filtering. So I can't do df pd is null on
Oh,
d
yeah.
yeah df2. Sorry, I don't think that will work. Huh. Yeah, I don't think that will work. But if I did it on a specific column like sepal length, I get that.
But how did it work? Like you didn't have that supplement, and then it was returning something.
So it's returning true because sepal length is null. So if I
Oh,
take that out,
ooh,
I'll get true
yeah,
for that. And so because it's true here, it's going to return
yeah.
this row. Yeah.
Okay.
And if I did the reverse, I should get is not null. Huh. I thought I would get everything else. I'm a bit confused. Anyway, let's keep going.
Okay.
So, here we go. So, replacing missing values is a common property. Pandas is
Mm-hmm.
really handy because we have this fill NA method.
Mm-hmm.
So if we have NANs like this in
Yeah.
df2, we can replace them with a value by just calling fill NA, and then we give it, say, some value. Let's give it like 0.0. So that will
Cool.
allow us to convert the NAs to a number, and that way
Mm-hmm.
it's not going to be mixed. Because the problem with NAs is that I believe if they are NAs, what would be the D time? What do you reckon?
Don't know.
So this has like numbers and NA, right? So
Yeah.
if we look at sepal length, oh, it is float 64,
Float.
so it's okay.
Yeah.
Yeah. But we want there potentially to be a value because if we do like a map function, if it's
Mm-hmm.
NaN, it's not gonna work. Or,
Right. Yeah.
So yeah. So we can add like any specific value to the data frame as well as like a specific, yeah, if we did it on a specific series, I imagine that would work too. So if we did sepal
Yeah.
length dot fill NA 1.0, and then if we did, we should get, oh, whoops. Maybe I shouldn't have done that. Oh no.
What is? Oh, so because you replaced that already.
Yeah.
Ah.
Oh, so
Wait.
wait. Let me just do df2 equals that, and then if we do that, what do we get? Okay. So so if I want to replace this NaN
Mm-hmm.
for this sepal length,
Yeah.
I guess I go df2.sepal length equals df2.sepal length.fill NA 1.0.
So it doesn't. Yeah.
Yeah.
Yeah. You started doing one. Right. Yeah. Okay.
Yeah.
Yeah.
And oh, that's it. So
What
they
can you fill all of them? Like just do fill all the.
Yeah. So if I
Yeah.
wanted to do that, I'll just do fill
You have
NA.
to. So you have to do that, right?
Yeah.
Because if you do that fill NA, it doesn't update it. You have to assign to a different. Yeah.
Exactly. Or you could do like in place equals true, I reckon.
Yeah. Okay.
So the other one is
Alright.
just this replace method, which I guess is like if we replace Setosa with Bebosa. Let's just try that. Okay.
Has no attribute. Replace.
I reckon.
Non-type. Where's non-type? Oh yeah. Wait. What was the non-type?
So non-type just means that it's trying to look for this method replace on df2, but df2 doesn't have replace. Df2, which is this data frame, does not have it. But if I do .species.replace, Oh, sorry. The reason why that's happening is because I did this. Yeah. So this is a danger in that, you know how I do df2 equals.
Yes.
Yeah. If you did in place, it's confusing because it's actually returning nothing when you do in place. So when you do in place equals true,
Yeah.
the return type of this is nothing.
Ah, right. True.
Yeah.
True. Yeah. Gotcha.
Yeah.
Yeah.
So actually what I wanted to do was just do this, and then if I did replace, does this work?
Yeah.
So we should be able to go Setosa, Bebosa. There you go.
Nice.
All right.
Cool. Yeah.
Let's go to the last one.
Bathroom break. I'll be right back.
No worries.
All right, I'm back.
All right. So the topic here is that if you might want to rename the columns, so instead of sepal length, we might want to rename it to something else. So if we do df2.rename, we can give it the columns, and then I think we give it the original sepal length, and then the value will be what we're going to change it to. So we just change it to something different. There we go.
Okay.
So it went from sepal length to something different.
Yeah, just something different. Okay, so this is how you change the column.
And then I assume if we did rows, we could do the same, where we go 0 to something else. Rename, okay, maybe not.
Right.
So columns was a thing. If we look at, so
because rows are like numbers.
Yeah, but it said that it didn't have rows, and I can't see rows here.
Oh yeah. I see.
So how do I change it from using columns to? Oh, okay. So alternatively, we can use the axes.
Huh. Oh yeah, true.
So by default, the axes is going to be. So index or columns, right? So index is the thing. So we can say, there we go, index. So if we use the word index instead of columns, we could potentially give it a dict-like. So we need to give a dictionary. So if I do 0 and then map 0 to something different, it should change this to something different, right?
Wow. Okay.
But it didn't do that. Maybe I have to give it like this.
Huh.
Oh, sorry. Rename index equals 0. And then that's probably still 0. Yeah. There we go.
Huh. Index equals. Okay, so the difference, I'm just comparing columns. Oh, yeah. So instead of calling columns, it's calling index. So where in the methods? Can you point it out to me where in the methods it was named?
Yeah.
Ah, so
So
it's not calling, right?
so columns was the first thing we used.
Mm-hmm.
And it said to me here, like it's using axis is equal to 1.
Yeah.
And this axis equals to 0. So
Ooh.
you could just say axis is equal to 0 and then do this,
Yeah.
or you could do axis is equal to 1 and do the columns.
Mm-hmm.
Alternatively, you can like use these parameters, index or columns, to do it, and
Yeah.
that's what I did.
With axis, how would you do with axis? Can you?
Yep. So like,
Yeah.
let's say I want to do this one, right?
Mm-hmm.
So this axis is 0. So
Yeah.
what I'll do is df2.rename axis
Yeah.
equals 0,
Mm-hmm.
and
Comma.
then give it the mapper. I guess I would do mapper is equal to 1 and then something strange. I don't know.
Yeah.
There you go.
Huh. Interesting.
Yeah, so the
Interesting.
key thing is it says like dict-like or function.
Hmm.
So
Mm-hmm.
because it says dict-like, I give it a dictionary. And by looking at the example, I can see that it goes from what it is to the value.
Mm-hmm.
So that's how
Yeah.
I figured that out.
Interesting. Okay. Okay.
So they show us how to redo the rows and the columns.
Mm-hmm.
And then you can even like change the axes, which I'm not going to do.
Mm-hmm.
Combining. So we combined two data frames with append, but now they're talking about some other methods like concat, join, merge. Yeah, this is worth knowing.
Yeah.
So given two data frames,
Yeah.
they use concat. So instead of doing Canadian YouTube dot append this one, the
Mm-hmm.
alternative to that is to do pd.concat and then a list of data frames.
Yeah.
So in this example up here, where we have data frame 1 and data frame 2, we could do the same thing. So if we had like, this is a data frame and this is a data frame,
Mm-hmm.
instead of doing df2.append df3, we could do pd.concat and then df2 and df3. So there we go.
What would the difference be? Like the advantage?
There's no difference. The
Yeah.
advantage is just that you can put a lot of data frames in a list.
Yeah, right, true. Because otherwise it would be you iterate. It would be like for this and then you do it multiple times.
Yeah, you would have to
This is
write df2.append df3, and
yeah,
then you would have
and
to
then
do like
the Panda for
exactly. Whereas this
yeah,
one, you just write a list and that's it.
yeah. Okay. Yeah. And then
Uh,
join and merge.
mm-hmm.
Yeah.
So
Well,
what do you reckon join does?
join sounds like the same, like putting them together might be different. I think I've learned this somewhere. Join it sounds it's not what it sounds like, so it's
Yeah.
very confusing.
So it says that join lets you combine different data frame objects that have a similar index. For example, if you have one data frame that has video,
Mm-hmm.
if one data frame happens to be trending on the same day in both Canada and the UK, we could do the following. So it has this data frame, set index title trending date, right? That's that. And then they do left.join. So they join the two data frames together. Yeah, because it has the same column names. Okay. Yeah, this one's a bit harder. It's actually really worth understanding this, but it's like a database join.
Yeah.
It's the same sort of thing. So
Okay.
let's say you have, let's say you have for each one of these rows an ID. So this ID says like 1 here, and then you have another data frame that has a bunch of information, and then you have 1. You can like create a bigger data frame that has all of this, but it matches the ones. So I think it's worth just creating a simple example instead.
Yeah, let's do it.
So let's just go with dfa is equal to pd.dataframe. And then we'll just create a dictionary that has ID. So we'll just have an ID field, and then we'll give it like 0, 1, 2. And then we'll have some values. Value A equals A, B, C. So that's the first data frame. And then I'll copy that and do a second data frame where the keys will be 1, 2, and 3, and value B will be D, E, F. Okay. So we got DFA, DFB. Okay. So if I join DFA, which will be left, on right, which is DFB, it will try and find the matching IDs. So let's just do that. DFA.join DFB. Okay, so now it doesn't work because it's requiring these suffix.
Yeah.
And if you read what this says, the suffix says that they're necessary because the parameters are necessary because the data has the same column names in both British and Canada data sets. So the error that we got is saying that the column overlaps but no suffix specified. So we need to specify suffix. So let's just put in the suffix by adding an L suffix and a right suffix, I guess. So let's just do that, see what happens. So we go L suffix is A and R suffix is B. So try and see what it did. Like try and interpret what it did.
So you put a data frame B on the right of data frame A.
So yeah, it just joined the two. It didn't merge them. It just joined them.
From merge.
Yeah. So like if this had 4 values.
Yeah. Would it work?
Yeah, let's see what happens. So if we put in D, look at that. So
wow.
It like
great.
It basically like merged it like from its side, and wherever it couldn't put values in, it put not a number. And it also like made this a float, even though it was an integer.
Why is that?
That's a good question. Like that to me would be incorrect behavior because originally these were integers.
Yeah.
DFB ID is actually integer.
DFB.
Oh yeah.
You meant to do DFB, yeah.
And then if we look at this now with DFC IDB is going to be float 64. That's wrong, in my opinion.
Maybe because they have two dimensions. So maybe if you make them both 3 rows and then see.
Yeah. Well, we saw that was correct. I mean, I think you're right that it's because of that. But the fact that it tried to fill you know how we had that fill NA thing? I think it did that for this. Yeah, you see, it's still correct. It's correct now when they're the same size. So one thing to keep in mind when using join is like what will happen. It also had merge. So if we use merge instead, let's just try and look up merge. So if we did dfa.merge, let's just look at how to use it. So we give it another data frame. We say how, which is currently set to inner, and we can look at what that means, but it says on. So I think on is the column to use to specify what to join it on. So at the moment, are you there? Hello?
Yeah, no, I'm looking at it.
Yeah, so at the moment, like these two have the same name, ID and ID. So I think if we merge on ID, it will look at those things and merge it. But if we had like IDA and IDB, we can specify left on to be IDA and right on to be IDB. So if they're on the different names, you can specify different the different names using those two. So let's just try that. dfa.merge.
Yeah, let's try it.
dfb. Okay, interestingly now, this one only gave us 2 elements. And why is that?
Because one of them is the same.
No, 2 of them are the same.
Oh, 2 of them are the same.
Yeah. So,
yeah, true.
Yeah.
It only returns the same.
It only returns the same, correct. And the reason why it only returns the same is because of this how inner. So it's saying like only return the matches. Whereas like if we change this to a different method, outer, let's see what happens. How equals outer. So
all of them.
Now it returns all of them and puts in empty values where the other one appears.
And if you had IDA and IDB, that wouldn't probably be a problem.
Well, it
Let's
would.
See.
If you so you think that if this was actually called IDA and IDB, you think that wouldn't be a problem? I think you'll get the same result.
Right. Well, let's have a look.
So instead of merging on just that, we go left on IDA and
what
right.
if you don't have that right on and left on?
If you don't have that, it will just try and merge it. Oh, in this case, it can't.
Because there's no commonality between the two.
Yeah, and I can't just do like on IDA. That won't work.
Because there's no IDA in B.
Exactly. But if I do left on IDA and right on IDB.
Right. So it has to have the same. Right. Yeah. Gotcha.
Yeah.
Yeah.
I mean, it can be whatever you want as long as they have the same thing. In this case, the IDs have the number that is. But you can see kind of like the power in that. If you have a very large data set and then you have another data set and you want to get like an intersection between the two. So let's say you have
method to do that. Yeah.
Exactly. So let's say you have one data set of computer parts that's from MSY, and then you have another set of computer parts from ScorpTech.
Yep.
But the common thing is like maybe the IDs of the GPU name is the same, And so what you want to do is like you want to find the intersection of just the data set that has
Yeah.
Scorptech, Radeon, whatever.
Yeah.
And as long as they're named the same, it's going to find an inner join of those things and give you all the
Yeah.
prices from both. And that could be
Yeah.
very useful.
Yeah.
Yeah. And that's the tutorial.
Cool. That's
Yeah.
awesome.
I think that's a good place to end.
Yeah.
I'll
Until
stop the
next
video.
time.
No worries. Subscribe or something.
Yeah.